Collision. It is an interaction between two masses, two objects. So when two objects interact with each other, this is about mechanics. This topic is related to mechanics. It means the two particles were so to collide, to take the collision. So for obtaining this phenomenon, we must need at least two particles. So two particles, here we will have one, and the second one here, we have the second one here. So these two are the particles. We need at least two particles. Okay, I will write this mass of the first particle with m1, and mass of the second particle I will write with m2. I'll represent the second particle with m2. So these two particles in mechanics, so if you consider the state of these two particles, they may be at rest or they may be in motion. State of a particle is represented by the displacement. If there is any change in its place, then we say that it is in motion. If there is no change in the position of the particle, we say that the particle is at rest. So to obtain the collision, to observe the collision, the interaction between these two particles, at least one of the masses, either mass m1 or m2, should be in motion. So at least one of the masses should be in motion, or two masses may be in the motion also. Either two masses or at least one of the masses should be in motion. Otherwise, collision cannot be done here. So they cannot collide with each other. They cannot hit with each other. We can say in a general term, hitting. They should hit with each other. So that hitting can be done only if one of the two masses is in motion. So we know that every moving body possesses velocity. So velocity into mass into velocity. So this is called momentum. We denote this momentum with P, which is equals to mv. So every moving object has momentum. So during this phenomenon, momentum is obtained by the mass which is in motion. If the two masses are in motion, both the masses have momentum. So we can say, I'll give you a better example for collision. The collision is nothing but the interaction between hitting of two masses. Ball hits the bat. This is a collision. If you play the carom board, striker hits the coin. Collision between the striker and the coin, and hit the ball on the ground or wall. Ball hits the ground and wall and bounces back. This is a collision. So we observe many examples in our daily life. Many collisions, types of collisions in daily life. So now in mechanics, we study, actually we should define what is collision in physics, not like in normal terms, just like a hitting, interacting like that. We should have a definition for collision, and then during that collision, so which physical quantity or physical quantities are constant or change during that collision. Next topic is how many types of collisions are there. So these are the concepts which are introduced in this subject, collisions. So to explain the phenomenon of collision, that is in a simple way, now I take a carom board. So carom board, we have a coin here on the carom board. So this is the coin. I will say this coin, we keep the coin on the board at one point. So this is mass M1. Sorry, I'll represent this mass with M2. Okay. And we will take a striker. That striker is somehow larger than that one. So I will denote this mass of the striker with M1. Now we will push the striker. When you push the striker moves towards the coin. So striker is moving towards the coin with some velocity. So it will have the velocity and it hits the coin. This is the collision. This is the interaction between the two. Hitting a coin by the striker is an example for collision. So it will have initial momentum, initial velocity. So this mass M1, the striker, so it will have the initial velocity. We denote with U, and it will have momentum also, which is equals to M1 U, momentum of that one. And now, so this striker, when it hits, just you might have played. So many of us play carom board, but casually we don't observe what happened there. Just we enjoy that game. Now, in physics, we have to observe the phenomenon of collision. If you observe, initially this coin, which is having the mass M2, it is at rest. But this mass M1, which is a striker, it is moving with a momentum mu, initial velocity. So in which direction? Direction is from left to right. Suppose we can say that one. So this is M1 U1 actually. So this is M1 U1. I'll write this one here. And for this coin, it is at rest. So its initial velocity, I'll denote with U2. This is equals to 0 because this is at rest. Now when the striker hits the coin, you can observe that this coin moves. This coin moves. Initially it has no velocity. It is at rest. This coin moves in certain direction. Suppose it is moving in this direction, this coin. So this is having some final velocity after hitting, and some after this striker moves in another direction. So this is the direction of the striker, and then it will have some other velocity. But if you observe the velocity of the striker, that is the velocity of mass m1, so slightly decreased, and it stops after traveling a distance. This mass M2 coin moves with high speed and goes towards the hole, this here, at the end of the edge of the carom board here. So this is a phenomenon, an example for collision. Initially, the coin was at rest. So in this case, here, what happened here? This striker, which is having an initial momentum m1, when it hits the coin, it gives a part of the momentum to the coin. It shares a part of the momentum to the coin. Then both will move. So here what is exchange? Suppose if you have some money, you will exchange something. You will share that money to some other, then both will have that money. Here also, the momentum of the body, first body, is shared to the second body and both will have the momentum after hitting that one. So this sharing of momentum, that we call it as exchange of momentum. So exchanging momentum is called collision. So exchanging momentum is the phenomenon when two objects hit or interact with each other. So this phenomenon is defined as collision. So the proper definition of the collision is the phenomenon when which the momentum is exchanged between two masses or two objects here. Okay, so in this phenomenon, the two masses may be in motion or either mass is in motion. Either mass is in motion here. It is not compulsory that the two masses must be in motion. One of them may be at rest. Here in this example, coin is at rest initially and the striker is in motion initially. Now, we will discuss which physical quantity is exchanged and which physical quantity is constant during this collision here. As I said, these two masses m1, m2, for a meanwhile, I will consider that both masses are in motion. Both are in motion. We are considering this case here. So for this mass here, initial velocity is u1. So it will have momentum. Momentum is m1 u1 here, and for this mass here it is also in motion. So this is the mass m2. It is moving with the velocity u2 and it is having the momentum m2 u2. Both collide with each other. So when both are colliding with each other here, so this is the collision. This is the phenomenon of interaction. So during this collision, this is the first mass. This is the mass m1 and which applies a force on m2. So it applies a force. So force applied by mass m1 is, I will write it as F1 and this is the mass m2. It applies a force on m1. So this, sorry, not this one. So it applies a force on m1 in this direction from right to left here. So force applied by the second mass, I will write it as F. Now, this is the phenomenon in which, as I said, momentum is exchanged and here meanwhile the two particles are in contact. Here collision takes place and during this collision first mass applies a force on second mass F1 and second mass applies a force on the first mass F2. Both masses apply equal and opposite forces on each other. According to Newton's third law of motion here, this is F1 is the action and we call F2 as reaction. According to Newton's third law, F1 equals to minus F2. This is action equals to minus reaction. So Newton's third law is obeyed during the collision. During any collision, Newton's third law is followed. This is the first point. So we can apply Newton's third law in the collision. So coming to the next point. As I said, momentum, here we have m2 u2 And for this is u1 for mass m1, u1 initial velocity, that one. After the collision, their velocities are changed. So after the collision, they have the final velocities. So they have the final velocities here. I am writing the final velocities. Final velocity of mass m1 is, I'll write it as v1, and it will have m1 v1 final momentum. So this is final momentum of m1. Next, we can take the second one. Second one velocity is also changed because they exchange the momentum. So second mass will have the velocity v2 after the collision. It will have the momentum. So this is m2 and v2 is the final momentum of m2. Yeah. So we have the momentum. Now we have calculated the momentum. We know that Newton's third law is applied during the collision. Now coming to this one. So this momentum is exchanged. Some of the a part of the momentum is shared by the two masses. It is observed. We can observe that. We can calculate that one. During any type of collision, whatever may be the type, I didn't explain, we didn't discuss that types of collision. So in the next class we will discuss, but during any type of the collision, any phenomenon, that type is momentum. What the momentum the system consists before the collision. Total momentum before the collision is m1 u1 plus m2 u2. This is the total momentum before the collision of the two masses. So this is must be equal to, this is equal to final momentum. So that is m1 v1 and plus m2 v2. Momentum is constant. Total momentum, not the individual momentum. Total momentum is constant. So here we have two concepts. One, during the collision, final momentum and initial momentum are equal. So this is law of conservation of momentum, linear momentum. Law of conservation of linear momentum is followed. This is compulsory. Definitely, the linear momentum is conserved here. And what about the next thing? And which physical quantity may be constant here? This is about the momentum. Next, we will come to energy. Energy, here, they, as both are moving, they have kinetic energy. They have kinetic energy. Both will have the kinetic initial and final kinetic energy. The kinetic energy is here we have equals to 1 by 2 m1 u1 square initial kinetic energy for mass m1 plus 1 by 2 into m2 u2 square for mass m2. This is initial kinetic energy. So I will write as Ke1. Ke1 is the total initial kinetic energy. And what about final kinetic energy? Ke2, I will write like this here. So final kinetic energy again half mv square, half into m1. Final velocity is v1 square plus 1 by 2 for the second mass m2 v2. This is the final kinetic energy. So during the collision, if you observe the momentum, this must be constant. This is constant during any type of the momentum. But about this kinetic energy, it may be or may not be constant. So depending upon the surfaces of the two masses, whether two masses are very smooth surfaces, they are having very smooth surfaces or irregular surfaces, or depending upon the type of the collision, whether it is between ordinary bodies or between two atoms, nuclei, like that. Depending upon the nature of the surfaces, this kinetic energy, it may be constant or Ke1 equals to Ke2 or Ke1 is not equal to Ke2. So in the next class, we will discuss about the conservation of kinetic energy.